these questions that have to do with speed and distance traveled. And one thing, if you don't have that formula in your mind, I just ask myself, well, how fast are you driving? What's an average speed if you're on a highway that you drive? 100 what? 100 kilometers. 100 kilometers per hour is your speed, okay? If you can think of that, then you can recreate the formula that all speed is, kilometers is a distance over a time. And that's the formula. Distance divided by time is equal to speed. And you can rearrange this formula any way that you like. So for example, if you multiply both sides by, and let's just use letters here. So this is the one that is easy to come up with because you just have to think of driving down somewhere and you can get speed as distance over time. If you rearrange this, could you see that you can multiply both equations by t? And you would get this equation. Distance is speed times time. If you're going 100 kilometers an hour for 2 hours, how far have you gone? 200 kilometers. And you just used this formula because you took your speed, 100 kilometers an hour, 2 hours, okay? And you would figure that out. And if you divided both sides by s, time is distance over speed. So you traveled 300 kilometers. You were traveling at 100 kilometers per hour. How long were you driving? 3 hours. And that would be using this formula. Now, these kind of equations and manipulating them will be helpful for us in this question. Because we've got a total distance here. He went upstream 10 kilometers. On the return trip, which was downstream, the average speed was 5 kilometers greater than its speed upstream. Right, and then simplify an expression for his total paddling time. Now, I'm wondering if you did some of these distance speed things in grade 10. Not sure, but we'll set up some stuff here. So we can go distance. We've got distance, and we're going here. Upstream, downstream. Can I erase this part just so we don't? So we're going 10 kilometers both ways. One way our speed is greater than the back. And then what we want to do is write an expression for his paddling time and his total paddling time both ways. So I'm going to make a chart here. We're going upstream and downstream. What I can do for this whole thing, we know that the distance in both cases is 10 kilometers. So right now I'm just organizing my data, because to try to go directly to an expression for this, some people are able to do that with ease. Other people get confused by the details, and so just writing our expressions all the way through is going to be helpful for us. What do we know about our speed? Well, we know that going downstream was faster than upstream, but we don't know what the actual values are. So I can use x, or I can use s. What would you rather use, x or s? X. So if we're going upstream and our speed was x, downstream our speed will be 5 more. And there's nothing for time given in this question, but because you know, again, speed is distance over time, and time is distance over speed by rearranging that formula, we could say that the time that it took him to do upstream will be whatever the distance, he went 10 kilometers, divided by the speed he was going, which will be 10 over x. So that's using the fact that time is distance over speed. And for downstream, again, traveled 10 kilometers, but now the speed was faster, so that time should be less. Putting this all together, our total time will be this time plus that time. So this is what the question asked us first. It said, write an expression for the total time, and then it said, simplify that. And what are we doing here? We're adding fractions. What do we do when we add fractions? We need a common denominator. Well, this one is grouped together. This is just an x, so this one's missing an x plus 5 and an x plus 5. This one's missing an x and an x. So when I multiply the top, I'll get 10x plus 50 on the first fraction and 10x on the second fraction. I have a common denominator, so I can add the tops. Yes, I have some like terms. 10x plus 10x will be 20x plus all over x plus 5 times x. And even though you could factor a 10 out of the top, nothing could simplify. So this is our simplified expression for the amount of time. And there's only one word problem in the homework to practice. That's question 11. So again, looking back at this one, you're going to need to know how to get a relationship between speed, distance, and time. And I would say go to how fast you travel down the highway to say, well, my speed was kilometers per hour to come up with this first one. And then you can rearrange it to get other ones. Set up your chart. We were going upstream and downstream. You knew the distances. You didn't know the speed, but you knew a relationship with the speed, so you could introduce a variable here. And then once you've got two things, you can find the other one via the formula, because time is just distance divided by speed. So I get 10 over x. That's how I got this bottom one. And here, 10 over x plus 5. And then from that, you can create the expression that we did here at the bottom and simplify. All right, so that is